We're going to be talking today about the changes to the U.S. TSCA, so new federal level materials restrictions in the U.S., and the changes to the Prop 65 warning. So if anybody attended this morning, it's a little bit different, adjusted from this morning. Lots of great comments about Prop 65, so I made the warnings even clear. So hopefully this helps. First, I have a little introduction, which is kind of what I'm doing right now. And I'm going to talk about some upcoming deadlines, give you an idea of how thick the number of new restrictions are for the next 2 years and what's coming up, plus a little bit of look globally. Then I'm going to go into the first one. I'm going to talk about TSCA. So I'm going to talk about really the first US product level, physical article level materials restrictions in the United States federally. What's the legal basis? What are the substances? What are they used in? What risks do they provide? Then I'm going to talk about some ways to manage it, especially some of the short deadlines. Then I'm going to talk Prop 65, which I've talked about a gazillion times. I'm going to talk about some of the enforcements to give you a better idea of how well enforced it is. Then I'm going to talk about the new warnings, which are still in the consultation phase, but I'm going to talk about what's being in consultation. There's some other changes about what your warnings are on the internet and catalogs. So I'm going to go through all of that in detail. So this one has even more detail than we had this morning. Lots of great questions, so I added up, sort of bulked up on the details, and then we're gonna have Q&A. So the idea is to be 50 minutes long. It was a bit longer this morning, and then about 10 minutes Q&A. So if you have any questions, feel free to submit in the control panel, and I'll try to get to as many as possible. So lots of stuff coming up, very busy. By the way, we're still experimenting with it. You might have me picture in picture. I am very much a hands talker. So I find when I was like trying to do things and show comparison with my hands, it doesn't work if you can't see my hands. I do apologize for my hair. It's a bit of lockdown hair. Well, at least you know I'm pretty sciencey because I definitely have the hair for radio. So hopefully it helps here. Lots of stuff. Next 2 years, super packed. I mean, we just passed a bunch of major deadlines. The skip deadline, any product imported into the EU after January 5th of this year, so a couple weeks ago, if they have reached SVHC above 0.1% by weight in any component, the product and the component, the SVHC have to go in the database. It's a requirement to sell. Lots of stuff coming up this year. UK REACH restrictions if you're importing chemicals into the UK. We have one of the first TSCA restrictions for PIP or TIPP 321. Often called 3-to-1, but I'll explain that. It's coming up a bit too soon. 2 different EU medical device regulation deadlines this year, the main one in May, and then the addition of cobalt in October, which affects stainless steel really heavily. Value restrictions for medical and laboratory equipment mid-year. Going into next year, tons of stuff. The next set of TSCA restrictions, which I'll talk about today, BDE, PCTP, and where they are. UKCAs next year. And then later on the second half of next year, likely second half of next year, we're looking at the new Prop 65 warnings, we're looking at the new Canadian restrictions, the new ROHS exemption variation. So pretty busy time coming up. Definitely globally, lots going on. I did not include in this picture all the minor consumer ones like India ROHS and Singapore ROHS, which are mostly a small group, say computers and dishwashers and such. But for most products, this is what you're looking at. Medical device, but sure, the only ones in medical device regulations. It's a larger range of consumer products than Swedish flame retardant tax, but by and large, most people have to obey all these different new restricted materials legislation. So really busy. I'm going to focus on the US ones today. A lot, of course, going on in the European Union, especially with the skip and the REACH SVHC updates. Canadian prohibition is going to have new restrictions probably next year. I'm going to focus on the US side today. This is a good graphic to show people all the different things going on. Saudi Arabia ROHS, we don't have a deadline yet, so it's not on here, but that's appearing in the next year or two. So globally, if you're selling products, there's usually some materials restriction you have to comply with. So first of all, talking about the US side, I have to explain a little bit its legislative basis because that will help explain what's going on. So most of the time in the US and Canada, the way it really works is there's some macro legislation that puts in the legal framework that makes it enforceable and the general guidelines and intentions and rules around the legislation. But it's up to usually a specific agency to actually implement the final rules. So for example, conflict minerals, the legal framework is section 1502 of Dodd-Frank. However, what you really have to obey is the final rule from the SEC. The Dodd-Frank section 1502 enables the SEC to create the final rule for conflict minerals. Same sort of thing here. The Frank Lautenberg version of TSCA creates the legal framework for the EPA to create rules or restrictions. If you go to TSCA, you won't find the restrictions we're talking about today. They're really implemented as final rules from the EPA. The legislation provides the EPA the power and process to do so, but not actually any of the specifics restrictions. You see the same thing in Canada. It's a very similar system with the priority substances, draft rule, final rule type situation, where CEPA, the Canadian Environmental Protection Act, enables Environment Canada to make risk management measures, like final rules here, the same sort of thing. So the way it works is the EPA then has the power, as long as they follow certain rules of their own. If they do not follow certain rules laid out in the legislation, any rule they make, they don't follow the legislation's rules, any rule they make can be struck down in court. So the first thing that has to happen, they have to identify priority substances. And a priority substance doesn't mean it has a restriction. By the way, they use the same term in Canada. The Canadian-US system have a priority substance list. Those substances do not have a restriction. All that means is they are priority to create risk mitigation or management measures. That means they're approved for money to be spent on figuring out what to do with them. So when they're priority substances, there's no restriction yet, but now money's going to be approved to figure out what they're going to do with it. They're going to actually create a draft rule on risk management measures. They don't have to create a restriction. There are many other options, labeling, groundwater limitations, etc. A lot of these ended up with restrictions, mostly in physical products. The newer law, Frank Lautenberg, allows restrictions in physical products, articles, not just chemicals. So a draft rule gets promulgated or sent out. Then industry will comment, and the SEC will, or in this case, the EPA will finally come back with a final rule. Now, the final rule, you will normally not be warned it's coming out. When we dealt with conflict minerals, and you see a lot of our work is in the final rule for conflict minerals. When we're working back and forth and giving feedback, the SEC couldn't tell us what they were thinking, nor could they tell us when it's coming out. It's part of the rules of the game, the rules of legislation. So when the final rule appears, suddenly, as it seems this January, that's actually pretty normal for the system. You normally don't get any warning. This rule can be still subject to court challenge. Because of that, they include many other things in it. They need to, A, show they did a draft version, that they sent it out to industry, that they got feedback, that they addressed the feedback, they identified and addressed the costs, and then created a final rule. So when you read the final rule, it'll be 3-4 paragraphs of content, and then page after page of what they originally thought, why they're doing this, what they originally thought, what they sent out, what industry's feedback was, how they addressed industry's feedback, cost assessment, and then the final conclusions. So it'll end up being something which could be 3 or 4 paragraphs long, ends up being 6 or 8 pages. So when you read it, you're going to, which one of these, the restrictions, because they'll have the proposed restrictions, the industry feedback of the restrictions, and their final restrictions will all be in the same write-up. They have to put it all in there to make them more bulletproof to court challenge. There's 1 or 2 here that are probably quite vulnerable because of the cost assessment side. So that's how it eventually works. So what we're dealing with right now are final rules. They're not the draft version. They came out in 2019. These are the final versions. These are the ones that impact you and your products. So there are 5 substances. There are 5 different final rules, by the way, that are now restricted, 4 of which are restricted in physical products articles. So these are really, in effect, the first product level, article level restrictions at US federal level. So we're talking US REACH types restrictions. More, they're really US versions of POP. These are mostly bioaccumulants. For a variety of reasons, it's very difficult to prove human harm in Canada and the US. The bar to prove human harm is very high. So if something does damage to you and I, it's actually very difficult to get it restricted. But bioaccumulants are much easier. The bar is much lower. So proving it causes bioaccumulation or harm to a fish is much easier to prove in North America. So most of the time when they're restricted, they're because they're bioaccumulants. If it causes cancer or reproductive harm or endocrine disruption, not likely to be restricted because the bar is so high. Causes bioaccumulation in the environment, much easier. So these are mostly bioaccumulants. There are 4 to 5 of them, and I'll go over each one individually, are restricted in articles, physical products. However, this is EPA. EPA restrictions do not apply to FDA regulated. So if it's FDA regulated product, EPA does not apply. If you're a medical device or pharmaceutical, you're FDA regulated, and therefore these do not apply. So it's kind of a little bit of advantage. If you're FDA regulated, these do not apply. These are EPA regulations. There's a letter separating the two from 1994 that the FDA regulated products are out of scope with this sort of thing. So most medical devices. Also, to add confusion, this legislation is basically structured to be published officially a day after the change of administration in the US. With the new administration coming in, they actually put a 60-day, pause is not quite the right word, review of it. Not to stop it, but they believe a number of the restrictions are actually not strict enough. We'll talk about the first one a little bit. So this pause, don't expect it to be making these go away. They're likely to make them stricter. There is opportunity though for one of them that it's really important to talk to your industry association to change. It does not have a realistic timeline. And so the way these legislations also work is they kick in basically 60 days after they go in effect. So restrictions kick in almost right away. Then any extended deadline is really called an exemption. And so it's something industry's asked for and they said, that's fine. We'll now say this is 2022 or 2023. And those are exemptions. I'll show some. There's one key substance is PIP, which is relatively common, that nobody asked for an exemption. So it's deadline 60 days from now, which is not realistic considering how common it is. And I'll explain that one. That's one that can use pushback, and I'll explain very specific reasons. The first one is 2,4,6 tris-tert-butyl-phenol, 2,4,6-TTBP. Now, a lot of these acronyms, which are not helpful. I have trouble telling them apart. I still have trouble remembering that one of the later ones is PCTP, which is also an acronym for another chemical, which is not helpful. This one is only restricted in chemical mixtures. It's not restricted in articles. This is also the one that has a strange restriction that is 0.3% in chemicals and a maximum of like 5-gallon buckets. And this is what the new US administration doesn't like. They don't like the fact there's some 5-gallon bucket rule. They find that really bizarre. So this is the one that might get stricter. However, it's only in chemicals, not physical products. So if you sell a lubricant where it's used separate of your product, there'll be restrictions. If the lubricant is part of your product, it's part of the article. So for example, if you sell your washing machine, you don't provide the safety data sheet for lubricants inside. It's an article. But if you sell spare lubricant, then it does count because that is a chemical. This is chemicals only. And most of them have a link down at the bottom. Hopefully they're hyperlinked. They're not all successfully hyperlinked. But if it's not hyperlinked, just copy over it, paste it in Google, it'll find it right away. So this is one that's not restricting physical products. It's the one of the 5 that's not restricted in physical products, chemicals only. So you're really only worried about lubricants you sell separate of the main product. Oh, I'm not, that's canceled. I just hit the hyperlink, that was the last one. Okay, this one, most people recognize, DecaBDE. It is the one PBDE in our ROHS, the polybrominated diphenyl ether, that we ever see. It's the only one we ever see for ROHS. It's banned under ROHS. It does not have a clear concentration limit in legislation, but however, you would not be reportable in a safety data sheet below 0.1% by weight. Under the new TOSC rules, chemicals and articles are supposed to be treated the same. So if you don't have to report in chemical form below 0.1, it's perfectly reasonable. 0.1 is the limit for physical products. It kicks in about 60 days. However, there are general exemptions. It's basically, in general, it doesn't kick in until Jan 6, 2022. There are some obscure ones from aerospace. There's also ones for curtains. So by the way, again, the way it works, if somebody asked for an exemption, they must have got it. One small hospitality curtain company said, hey, we have a lot of stock and inventory. Can we do 18 months? And EPA said yes. So what was asked for was generally allowed. Wire and cable, which is the main use for DecaBDE, it's one of the best flame retardants for very thin plastics. Thin plastics like heat shrink have trouble passing the ULB0, the candle test. They burn too easily. So there's a handful of flame retardants that work really well with antimony trioxide. One is DecaBDE. So wire and cable, where its main use is, has till Jan 6, 2023. If you're ROHS compliant, you will already meet these restrictions. But if you're not ROHS compliant, possibly because the product is not sold there, possibly because you're fixed installation, something else, you now have a DecaBDE restriction here in the US side. So again, anything that's basically asked for in terms of deadlines is actually generally approved. And the reason it was asked for DECA is DECA has been regulated for so long, many companies knew whether they had it or not. So anything that's been regulated somewhere else in the past usually has a lot of information on it. So the companies were able to be much more specific on why they needed exemption. Some of the other ones in a minute, which they really needed, since they've never been regulated before, the companies and their supply chain had no idea it was there. So you run into a bit of a problem. We'll talk about PIP in a second. So this is Pentachlorathiophenol. It's a chlorine and sulfur compound. It's restricted in articles, physical products, and chemicals at 1%. Its deadline is January 6, 2022, with a few minor obscure exemptions. Where you find this is an additive, mostly plasticizer, but really got a different property, in butadiene-based rubbers. So nitrile rubber is nitrile butadiene rubber, SPR rubber is styrene butadiene rubber, and isoprene is butadiene rubber. If you look there, it's not as easy to see, but if you know, I lined the left side up, and you notice all the butadiene. Butadienes are CH2 bond, CH double bond, CH bond, CH2. That's a butadiene. It's all the butadiene rubbers, of which MBR and SPR are also generally phthalate risks at the same time. Isoprene is not. So it's the 3 rubber types. So this risk of this chlorinated, sulfur-based compound, usually with zinc vulcanizer, is in the butadiene rubbers. So we're looking at a risk for Jan 6, 2022. You should focus on your butadiene rubbers. It's not your TPE, it's not your EPDM, it's not your PVC, it's not your Viton, silicone. This is the butadiene-based ones. So restricted to 1% as of January 6th, so less than a year from now. Your main risk area physical products are the butadiene rubber family. And we'll talk about in a few minutes about practical ways to handle these deadlines. Now, if you ask your supply chain what they know, nope, it's never been regulated before. The chance of them having information in their supply chain is nothing. You say, hey, I have a full material declaration. Let's look it up. It's an additive. It's not included in the polymer. Polymers, rubbers, plastics, they don't have to declare additives under CAS rules. So if you say, I declared the CAS level, I'm like, great, that's each CAS number is a soup. It can be many, many things inside. They don't have to be pure. So you're gonna have to redo all of that work. And unfortunately, suppliers generally won't even have the information. There's better ways to do that. This is the problem child, it's PIT. And it looks like ratio 3:1, and I would read it as ratio 3:1. It's phenol isopropylated phosphate, but it's not a ratio 3:1. It's kind of hard to see, and I'll show a little better in the next page. It's how many isopropyl groups it has. And I'll explain that in a little bit. It is a relatively common phosphate flame retardant. It's not otherwise regulated today, except for obscurely under the Swedish flame retardant tax. So a handful of companies we work with do have some details because of the Swedish flame retardant tax, and it's not an uncommon material. It's actually in physical products, it's in lubricants, it's not an uncommon material. It's actually the replacement for DECA-BDE in many cases. So its restrictions 1%. It kicks in 60 days after February 5th, which is April 6th of this year, which is not enough time. If somebody asked for an exemption, it would have been granted. Since it's the replacement of that one, and this one's allowed wire and cable to Jan 6, 2023, it would be perfectly reasonable this was Jan 6, 2023 also. This is something you need to go to your industry association and say, hey, look, this is out there. Our supply chain has no idea. It's worse than DECA because it's not a replacement for DECA. It's not otherwise regulated, so nobody has any idea. It's in flame retardant PVC. It's in polyurethane foam, like cushion foam. It's in BPA diglycerol ether epoxies, which might not mean much to you. FR4 circuit boards. Flexible circuit boards, those are BPA diglycerol ether epoxy. Now, if your circuit board's brominated, which it normally will be, that's tetrabromo bisphenol A, and there's no reason for it to have a phosphated flame retardant. So most circuit boards won't have it because you use a brominated one, but as people move to halogen-free, they start using the phosphated ones. Most common being triphenol phosphate, which I'll talk about in a second, which is sort of a subset of this one. This one definitely is used. It's isopropylated phenolphosphates, often unnamed TIPP. It's also used in polyurea flame retardant lubricants. So if you have a fire area, they use polyurea lubricants, often in rollers or engines. It'll very commonly have TIPP, or PIP 3-in-1 is its name here. So relatively common, has a very, very, very short time frame. This is the one that's worthwhile industry going back and saying, hey, look, we need an exemption the same as DECA. If you say it's a DECA replacement, then it should have at minimum the same timelines as DECA. Phosphated flame retardants are super common. Do we test for phosphated flame retardants? All the time. We don't necessarily test to specify this one. We know there's a phosphated flame retardant, but because this one has not been regulated outside of Swedish flame retardant tax, we would not normally have checked too deeply. But we see phosphated flame retardants all the time. They're very common. As people went halogen-free, as halogen-frees move away from chlorine and bromine, not fluorine for some reason, as they've done that, they often move to the phosphated ones like this. So halogen-free often means phosphated flame retardant like this one. This is one of the common, it looks like, phosphated flame retardants, Will your supply chain know much about it? Nope. The lubricant guys might, because it's in the safety data sheet. Otherwise, your supply chain data is going to be poor. Another problem with it, PIP 3-in-1 is really PIP 3, PIP 2, PIP 1, and maybe PIP 0. So the EU chemical list includes PIP 0 for it. What the difference is, and it's hard, and it's a little bit tricky to explain, is it's how many isopropyls they have. So the one on the top left has 3 isopropyls. What are isopropyls? They're that whale's tail. You see the benzene ring, the hexagon with the double bonds, has a little whale's tail sticking out of it. There's a stick with a little V behind it. That's an isopropyl group. Yeah, I have trouble. Methyl, CH3, butyls, this one, isopropyl's that one, ethyls, 2 C's in a row. This is isopropyl. Isopropyl is that little whale's tail. The one on the top left, 3 of the benzene rings, 3 of the hexagons have the whale's tail, so that's PIP 3. The one on top right, 2 of the benzene rings have whale's tail, that's PIP 2. It's isopropylated, isopropyls on 2 benzene rings, those are 2. PIP 1 is the bottom left, the whale's tail are the isopropyls on 1 benzene ring, and then there's PIP 0, which I wouldn't think counts, but it's in the picture on the EU side, and that's triphenol phosphate. Triphenol phosphate is probably the most common phosphate flame retardant. It's also an endocrine disruptor and will likely otherwise get regulated someday in the future. But in practice, that's the main halogen-free flame retardant. Is this in scope? Is triphenol phosphate in scope? It does not seem, but is not clear, to regulate triphenol phosphate if triphenol phosphate is on its own. If it's in amongst the other 3, then it is, because it's then TIPP, which is phenyl isopropylated phosphate 3-in-1, or PIP 3-in-1. PIP 3-in-1's other name is TIPP, which is the isopropyl phosphate. TIPP, PIP 3-in-1 are the same thing. It's a combination because when the chemical's made, it may have less or more benzene rings properly bond to the whale's tail. So you have a variety between 3, 2, and 1. And you have some cases never bonded, which is 0. So our belief internally right now is PIP 0, which triphenol phosphate on its own does not count, because otherwise that's a super major restriction. Triphenol phosphate is everywhere. It can be amongst the mixture, but it's only included if there's a mixture of them. The other ones do not exist. It's a different CAS number, which is PIP, which is triphenol phosphate, not PIP, because it doesn't have an isopropyl. Saying that's one of the isopropyls when it has 0 seems a bit unfair, but it can be in the mixture. On its own, TPP, we believe, is not included. But that's another good one for the industry association to clarify. If we have triphenol phosphate on its own with no isopropyl groups, we're good, right? So it's very, very common. We hope so. Otherwise, there's going to be a tremendous amount of product redesign in the next couple months. Triphenol phosphate is everywhere. The last one, 5th one, hexachlorobutane HCBD. It's actually banned already in Europe under POP. It's likely, I believe, it's Canadian prohibition restricted also. Fortunately, it is also banned in articles at what looks to be 0.1%. There's no limit, but it wouldn't be below a safety data sheet declarable limit. So 0.1% in articles. It's an intermediate of an intermediate. So imagine you're using a chlorinated flame retardant in your polyolefin, your heat shrink, and say it's the chlorine plus, and you make the chlorine plus from other chlorinated substances, and you need originally to get the chlorine. The chlorine you eventually have to dissolve from chlorine solid. HCBD dissolves the chlorine solid to get the chlorine to make the ingredients to make the dechlorine plus, which you eventually add to the heat shrink. There's not going to be any residual HCBD of any real concentration in the final product. So this one's very low risk. It's an intermediate, solvent intermediate of an intermediate to a chemical that may be rarely in your product. So very low risk. It's a solvent, many chemicals back in the process. So this one is very low risk in your physical product, which really brings it down to 3. PBDE, which if you're ROHS compliant, you won't have to worry about. PCTP, which you're looking at the butadiene rubbers. And then PIP 3-in-1, which is a much bigger problem. You're looking at flame retardant PVC, you're looking at circuit boards that are halogen free, and you're looking at polyurethane foam. But it can be used in other places. It is a phosphated flame retardant. So how we do it? Legacy products, you can't solve everything for every product you've ever made. It's really difficult. So when we do a lot of this work, we work for the best compliance possible and the least chance of getting in trouble. So no matter what you do in data gathering, your supply chain will make mistakes all the time. What you really want to do is create a structure that you can be as best compliant as you can, and if you make a mistake, there's human beings involved. You're also people are pushing for cheaper parts, cheaper materials. There will be mistakes. You want to, when a mistake is made, and if it's discovered, There's no penalty for it. And then the US and Canadian side, they're really good about this, is it's strict compliance. You have to be compliant. If you're not compliant, though, the penalty has some leeway. And the first thing they ask for, no, they don't ask for supplier declarations. A supplier declaration, if you're non-compliant, means zero in the US or Canada. They're used to toys, where the toy manufacturer always says, hey, look, the supplier said it's fine. And they're so used to that, like a dog ate my breakfast, they don't care. It's not going to give you any legal defense. All they care about on the North American side is whether or not you've tested adequately. They don't expect you to be perfect, and they have a very different look on your value of sales. You do billions of dollars, very different look than you say, hey, we sold $10,000 worth. They're like, we don't really expect much. So what we do for this situation, legacy products, we take representative products like we did for Skip, and then we select the highest risk parts, and we usually select more. Say, hey, we select 15 parts from this product. You provide, as long as you provide us 10, we'll screen for those 10 because some of them might not be easily available, and there's a time frame issue here. So then we screen for them, and then we solve by testing in weeks the whole problem. Your supply chain won't have any reasonable data in it. If they give you any data, it'll mostly be just untruths to make you go away. The fastest, most rapid way to do it is through testing of selected parts from represented products. You can't do everything for your legacy products. You can't fix the world overnight. What you want to do is do enough to know if you're on majority compliant, and you want to be able to show somebody something goes wrong. Look, I did test represented parts. I had zero. We had nothing else to go on. New products, we have a different approach. New products, we normally enter into a comprehensive test process. A lot of people scare you trying to sell you database services. Testing is not that expensive. It's actually much cheaper than data gathering. What you have to do, though, is be smart about what you're doing. So most of these regulations all have overlapping substances, and many of the substances which inside the overall chemical, which are super easy to detect. Does it have tin in it? Nope, it can't have any of the tin substances. Does it have nickel in it? No, it doesn't have the nickel substances. Is it EPDM? Yes, okay, then it could have this. So using screening technology and the fact that so many regulations are overlapping, you can do them all at one time in weeks, not the months it takes to get half the data from your suppliers normally. We definitely do recommend having a very short supplier spec so they know what they have to be compliant to. What we're seeing more for larger companies is corporate level sets the compliance spec. These are the regulations you have to be compliant to. And the business units have to achieve compliance because they are usually the ones with the product development budget. So here's what you need to get out of pre-manufacturing to manufacturing. You need to comply to this. Then their engineers and designers and procurement have something they can provide to their suppliers. And instead of writing on a drawing must be ROHS compliant and then changing every drawing every time a registration changes, it says must be compliant with ACME spec 1, 2, 3, 4, and then you update, you reissue your spec every year to your suppliers. And if you haven't issued a spec to suppliers, then what's the point of data gathering? Because you're asking for stuff you never asked for when you had them buy it. Any data they gave you is very, very suspect. If you want it to be compliant with something, then ask for it before you buy it. It's much easier to get compliance before you buy something than afterwards. What's the point of asking for data after the fact for a product that you never asked the manufacturer to design that way? ROHS, the supply chain has reasonable data. We still get ROHS failures all the time. The supply chain is fairly incompetent, but they're fairly knowledgeable in ROHS. The rest, it starts going downhill. This solves all the problems at one time. If you're trying to sell a product globally, testing new device, they say, hey, to come out of pre-manufacturing, pass this test suite, we have objective evidence, move on. It's a lot easier and cheaper for everybody and faster. You can tell your management, I'm be done in this number of weeks, not that 2 months in, I'm like, I got 50% data and we have these other problems and this long convoluted story to the executive who has this amount of time. All they want to know is when it's compliant. So testing provides huge advantages to that. So on the other side, Prop 65, and this is if you are watching this morning, has a little bit of a little difference. I added more detail. The warnings are the devil's in the details of this. But first off, we wondered going into COVID whether or not there'd be more or less Prop 65 prosecutions. One of the thoughts were everybody's gonna be staying at home, so it's gonna go down. So it used to be 200 prosecutions a month. Pretty consistently through COVID, it's been up to 300. So it's easily the most regulated and prosecuted research and materials legislation in the world. It averages well over 300 prosecutions a month. Physical products, it's primarily around things you can touch. The main prosecution model for physical products is ingestion. And you're going, what do you mean? Nobody eats my product. This is ingestion. Literally, the court case when we defend somebody is you touch something, and it comes off in your fingers, the rule pre-COVID is the average American touches their mouth 8 times between hand washing, and 50% of what ends up in your fingertips is transferred to your mouth. It's actually primarily through the act of eating. It's not necessarily touching, it's eating food and transferring the food to your mouth. So one of the reasons why COVID has one of the main preventions is disinfecting the hands, because 50% of what ends up in your fingertips gets transferred to your mouth, normally through the act of eating. One of the most risky areas for infection, probably the primary one, is hand cleanliness during the act of eating. 50% of what ends up in your fingertips gets ingested. So when we do a prosecution for lead or defend it, if somebody's touched it, we do a wipe test. 50% of what comes off in the wipe test is ruled to be ingested. Now, lead's a little different than COVID. Lead is about being ingested, getting down in the stomach and getting in the bloodstream. COVID's about going to the back of the throat, attaching to the epithelial at the back of the throat, and then spawning from there. So it's a little bit different mechanism when it gets to your mouth, but the idea again is transfer to your mouth. So whenever we're looking for Prop 65 prosecutions, almost all of them around what comes off your fingers. In an accessible part, you have to be able to touch it. Lead and brass or lead and ceramics. When you have a ceramic tile, blue or green is normally leaded. It's hard to actually make dyes that are not leaded with their blue and green for ceramics, because most organics get disintegrated in the kiln process, and they come off in your fingers. The ceramic tiles, usually those funny colors, come right off in your fingers. It's also why a lot of food contacting dishes, the red or green ceramic, red's cadmium, is on the outside and the inside is white, because they rule the outside is not a food area, so it's allowed to come off for food contacting. Prop 65, though, it is accessible. So PVC, normally it's cables, if what comes off in your fingers. Phthalates generally do not come off in the sweat acid of your fingers. It's not soluble in sweat acid, but they come right off in the sebum oils, and they bleed right out of the wire. So it's what comes off your fingers on a wipe, and the rule 50% of what comes off in the wipe is ingested, and is that above the daily exposure limit. Many other types of prosecutions, all are ingestion except for one. So lead in seafood and dietary supplements, ingestion. Cadmium in seafood, ingestion. Acrylamide is the brown or black that gets created when you toast something, ingested. Coconut, DEA, coconut shampoo, and yes, it's ingestion. And furan, which gets created when you make onion soup. Don't know why. It's a very simple chemical structure that somehow gets created during the manufacture of onion soup. The titanium dioxide one here is different. That is an inhalation exposure. So titanium dioxide will be the most commonly declared Prop 65 substance by your suppliers. It's quite correct on their part, but it's not declarable for you. Titanium dioxide is a physical carcinogen, like asbestos. So asbestos is chemically inert, like titanium dioxide. Asbestos is rock. Titanium dioxide is a crystal. And asbestos, you inhale, it gets into your lungs, and it's a little spiky. And since it's rock, it's insoluble in your lungs and spikes up your lungs and cuts them up. It creates redness. Once in a while, that redness heals wrong, and that's cancer. Most cancer is a bad healing event, which is more likely as you get older. So whether it's sunlight, which it's not the actual sunlight that causes cancer, it's the sun damage, it's scarring, and the scarring sometimes heals wrong, and that's cancer. The cancer risk with COVID is the scarring in either the nasal cavity or the lungs from the spawning event. That scarring can heal wrong, and that can be cancer. Titanium dioxide is a physical cancer also. It's the inhalation, chops up your lungs. Once in a while, it goes wrong, the healing, and that's cancer. But only when it's inhaled. It's not a problem in an uninhalable situation. So you'll often see in your white or light colored plastics, if you look at the safety data sheet for the plastics, in section 15, it'll have a warning for titanium dioxide, Prop 65. That doesn't apply to your white pipe or white enclosure, your white plastic piece. Your white plastic piece is not inhalable. That safety data sheet is not for your enclosure. It's for the bag of pellets or the bag of flakes. So the person molding, that's a dust risk. There is a titanium dioxide inhalation risk. The person molding, pouring out the bag of pellets and flakes. Once it becomes your tube, it's no longer an inhalation risk. So this particular one is loose powder sunscreen. So titanium dioxide is mineral sunscreen. Normally it's applied in a grease. It physically goes on and blocks the sun. The other common type, the easy one, or the chemical one, which is benzophenone octosalate. Both are Prop 65 reproductive toxins. They're endocrine disruptors, should never be placed upon large surface skin area, large dermal areas. These ones are harmless on dermal areas, and normally it's grease. Titanium dioxide is grease, or zinc oxide is a different variant. There seems to be a loose powder version. The powder titanium dioxide is inhalable. So this titanium dioxide is a Prop 65 risk. The titanium dioxide in your plastic, once you make it into a physical part, is not. So we're primarily looking for risks. And so when we do testing and exposure analysis, and we're probably easily the top lab in the world for the Prop 65 and physical products, it has a lot to do with exposure. For most cases, not all, it's around physical contact and then how much comes off your fingers and is ingested. Wearables have some different rules. Safety goggles have different rules. Long-term exposure can have dermal, but by and large, if you touch something, it's around ingestion. So it's all ingestion risk. So going to the new warnings, today, the warnings are pretty straightforward. If you put the warning for substance, so imagine you have an exposure, you think you might have a Prop 65 exposure, you either have to get rid of the substance or place an appropriate warning on the product or packaging. If you put the warning on the product packaging today, not the new rules, you can use a short form, which is !warning, warning caps, cancer reproductive harm - Government of California website. You don't have to identify the substance, which made it so easy for companies just to slap on this generic warning. If you put it as an insert, or you can justify putting it in the manual, you have to use the long form. The long form has to identify a carcinogen and a reproductive toxin. And lead compounds happens to be both. So in some situations, one compound checks both carcinogen and reproductive toxin boxes. But if you put it on the product or direct packaging, you can use the simplified form. And what California is finding, people are just slapping it on without really knowing what's in there and not really providing a useful warning. So that's what the change is about, getting rid of that slapping a generic one on. So they're going to require a substance to be identified in all products, even in the short form. The short form will also have to be set off. They're still allowed a short form, but it has a substance in it, just a little bit less text, and it has to be set off from other surrounding information and enclosed in a box. This is more detailed than I had this morning. There's lots of good questions. The long form still needs to be used in all but the smallest products. You have to identify one reproductive toxin if you have one carcinogen if you have one, or if you have a substance that happens to be both, like DHP or lead compounds, you can use it for both boxes. So you need to check both boxes, one of each. If you have 3 reproductive toxins and 2 carcinogens, you only have to identify 1 reprotoxin and 1 carcinogen. If you happen to have a substance that's both, you only have to identify that one substance. Lead compounds checks both boxes. So you're gonna have to you're gonna have to know what the warning's for. You're gonna actually have to put the chemical on. You can't slap the generic one on. So there's a new short form and new long form. Again, this is in consultation. It finishes March 8th. There might be minor changes, and it's likely coming into effect for products second half of next year. The way that it's written is a bit obscure, but it's basically 1 year from going into effect. If you use the short form, which is still allowed on certain small products, you still have to identify a substance, like this one, a warning, risk of cancer, reproductive harm, lead compounds exposure, the Government of California website, the exclamation point, the triangle, has to be in yellow if where you have it has access to yellow. If there's no access to yellow, it can be black and white. And if it's used in small form, you have to put a box around it. If you use the long form, you don't need a box. This product is exposed to chemicals, including lead compounds, which is known as out of California to cause cancer, birth defects, or other reproductive harm. For more information, go to, that's the long form. You can always use the long form. Certain small products can use the short form, but it has to actually still have substance identified, and it has to have a box setting it apart from other things, which probably makes it even scarier. Long form doesn't seem to need a box, strangely enough. So right now it's in consultation till March 8th. We expect a decision by mid-2021. It's written a bit strange. It looks like it goes into effect 1 year for the effective date, which might be 1 year from 1 year. So they'll write, the effective date might not be for a year after it's approved. It might be a year after that. So that needs to be clarified on how that effect works. But we're looking at very likely the new warnings kicking in by second half of next year. So it's whether it's a year away or a year from a year is not easy reading. We will see in the final text what the exact deadline is. But what companies will need to be prepared for, they'll likely need the new warnings second half of next year, where they'll have to identify substance or substances, depending on the situation. It's a big change. You can use the short form, which for better or worse includes a substance information if the surface area of a product label is less than 5 square inches, if your packaging size cannot accommodate the full warning, which is not significantly difficult size, and there are some font limitations where it can't be lower than 6-point type. And it has to be no smaller than the largest type of font used for other consumer information, which is a bit of interesting. Consumer information is not the product name. It's like the product contents, that kind of thing. It has to be that size. So the warning is large. When in doubt, most products don't need a warning if you do the proper evaluation. And I'll explain that in a moment. Some do, most don't. The other change is internet warnings. They say the internet has infinite size, so you have to use the full warning for the internet warnings. You can't, right now, if you use a short form on the product, you're allowed to use the exact same short form on the internet. So you can be generic on the product and generic on the internet. Now they say you can't do that. You have to use the long form. Catalog warnings also need to use the long form. Again, in both cases, it's only in situations where you can buy it in the internet or by catalog. If you can't buy it in that location, you don't necessarily provide a warning. The internet requirement is the warning to be provided before checkout. If you cannot check out on that site, then there is no specific warning requirement. So the internet warnings will have to use the full substance one. So how do we handle this? We're easily the top Prop 65 lab in the world. We're very definitive. We do mostly preventative. We also do a lot of court defenses. We've done everything. We're usually one of the leading experts in this by a mile. Normally done by testing. The supply chain data is not terribly useful for this. It's about exposure. It's not about what the ingredient is. It's about your product and what can be exposed. However, fortunately, exposure does limit the number of parts involved. It is a little bit different for certain products that have a very different risk for a consumer versus a repair technician. So your refrigerator, generally the consumer parts don't have a Prop 65 substance of above exposure limits. However, if you open up the back and you start playing around with the compressor, there are some leaded brass components which provide the repair technician with an exposure. So it's quite different. We do screening of substances. There's a lot of ways to easily screen. Based on the screening results, we have follow-up testing, whether by concentration, by exposure. Every single chemical is a different pathway. We basically have done tens of thousands of these. We have basically a solution pathway for virtually everything. Ethylene oxide for medical is a little bit more complicated, and that's sort of a longer conversation. But virtually every single Prop 65 situation you run into, we have the solution path, including ones that don't have safe harbor limits. There is a path for all of them, and we'd explain in each situation that works. One of the other things we're working with is when we give you a test report, it's not like, woo, lob it over the fence and good luck with that. No, we'll actually explain it. They're like, well, what's going on here? You're not non-compliant. You're compliant as long as you provide this warning for this substance, and this is why. If you replace that part there, you don't have to do it anymore. Or we'll may just say, you don't have to provide a warning. You're not above the exposure limit on anything. Or in a lot of cases, you're above an exposure, but only for the repair technician. So that can go in the repair manual. You don't need a consumer warning because the consumer doesn't have that exposure. Now, the other nice thing is we solve it conclusively in weeks. So basically, we have the product, we'll solve it for you. Here is the answer. And for legacy products, it might not be able to solve every product, but what's your representative product? You probably have so many products that are so similar, that product, or whether or not that's one's declarations are the same for everybody, but the risks we identify, whether that one's above or below an exposure limit, are probably common across the board. So that one has leaded brass. Turns out the exposure is below the exposure limit. However, you have that part varies from across the product line. Is it just safer to provide the lead warning? And we help you with that. We're very, very specific. It's the best. We are the best way to get an answer. New designs, easy. You put Prop 65 with everything else. Tosca and RHS and REACH, SCIP and POP and asbestos and all those things. They have so many overlapping substances and screening requirements. It's just a matter of being organized and having a pathway. Doing things serially one after another makes no sense. Do them parallel. And it's done in weeks, basically saying RHS is one thing, but amount of time you really have to be compliant with 20 different things. We take care of those 20 different things, give you an answer. Some of the answer is you're compliant. Sometimes it's non-compliant. Many times is you're compliant as long as you have this warning or this label or this registration. And this is what you have to do, and we'll help you. We're very, very specific. You're not doing this for fun. I'm kind of doing it for fun sometimes, but you're not doing this for fun. You're doing this because you need to sell to market. We want to focus on giving you exactly what you need to sell that product in that market without getting into trouble. And when the situation's imperfect, like Tosca could be, if something goes sideways or wrong, we want you to not be in a situation where there's any penalties involved, because it's very fluid. The EPA doesn't even know where the chemical's used half the time. It's not a perfect situation. What's the best way, especially with representative products and representative parts, to get the best compliance? And if things go sideways, which they tend to, human error is a major factor in that, there's no penalty for it. So contact us. We'll be happy to help. We can solve this for you. So again, lots of stuff going on. That's one of the reasons for new designs we say, you know what, just give it to us to test. There are 10, 12 regulations if you're selling it globally. They have such overlap. Your suppliers, their knowledge base will start falling apart after ROHS. The REACH SVHC substances are updated all the time. They're also very confusing. We can solve it. Just, that's what we do, we solve it. It's kind of a simple thing. This is all getting really complicated. Claigan just solves it. And a lot of the companies we're working with, we've been working with for well over a decade since we first opened our doors. We really focus on what you need. I'm sure everybody says that, great, but we actually do. So again, testing, Tosca Prop 65 is usually the best way. However, there's some consultation. Like, we do explain what to do with it. You have these results. That's awesome. It's not like, here's the test report. Good luck, sayonara. See you next week. No, we actually can explain. We'll actually explain all the details and help you as much as you need. So that's a big part. New design, easily the best way. One regulations might be doable, two, and then once you get above two, it starts to get crazy. And what we hate, we used to do data gathering, and what we hate, one, the quality is so horrible, it doesn't meet any of your ISO requirements. So just for ISO reasons, we had to get rid of data gathering outside of very technical reasons. But what we didn't like is like, okay, we got 60% of the data, and we don't know where we're gonna get the rest of the 40%, and we don't really trust the data anyways. And most of the components that could have our substance are in the undeclared parts, and the suppliers have no idea what we're talking about. And I love when I get a certificate saying we're REACH compliant. Okay, the thing is, with restricted materials, your product is not, your compliance is not based on your best suppliers. Your compliance is based on your worst suppliers, which makes data gathering even more of a vulnerability. So again, if you have any questions, please put it in the control panel. I'll try to get to as many as possible. We're just going to flip over the questions right now. Before I get there too, don't forget, I mean not forget to tell you that everybody who registered will receive a copy of the slides. And these slides, the one this morning, didn't have as much detail. These ones are a lot better. The guys this afternoon benefited from that, I hope. And the recording of this will be online, available to everybody in the next couple of days. Are electronic products regulated by the FDA? Does that exempt them here? No, electronic products are not, are regulated by the FDA if they're not FDA regulated products. So medical devices are FDA regulated. So most products are EPA. Medical devices are FDA, pharmaceuticals are FDA. Everybody else is EPA. You could argue about certain parts of it, but if it's an FDA approved device, it's actually FDA exempted, those ones are out. So it could be FDA requirements that apply to certain products, but they're not really FDA products. So medical devices are out of scope. Everything else is pretty well in. Any indicators of whether there'll be a sunset date for the medical device exemption from the FDA? That would take a legislative change. Believe it or not, the justification for this is a 19 pair of 1994 letters from the EPA saying the FDA stuff's not regulated. It's up on their website. They are literally scanned in. They're a little bit crooked, like usual. But yeah, no, the exemptions from 1994 letters. They'd actually have to change the legislation for that to change. So right now, that exemption is not expected to go away, and I don't think the FDA wants the EPA to get those powers. What is the enforcement mechanism for TSCA substance reporting? It is strict. Strict means you can't have it. They can use any method they deem necessary. When we deal with the Canadian version of prohibition, which is very similar legal structure, it's farther along, they literally have enforced people show up with badges. It's primarily, for physical products, it's primarily testing. For chemical products, it's primarily safety data sheet review. And they have to respond to any report, but it's strict liability, which means you have to be compliant and they can do whatever they feel to make sure that happens. And they have like EPA officer type stuff that can enforce in a much stricter way than we're used to in Europe. Are Prop 65 warnings for consumer products only? No. The consumer products have more specific rules. Professional products have a broader rule set. The difference is the exposures covered by Prop 65 are three. Consumer exposure, which by the way, for medical devices includes patients. Occupational exposure is in scope. That includes workers, repair technicians, healthcare practitioners, workers. Environmental exposures. You have a car wash and it flushes down the drain, that's an environmental exposure. All three are in scope of Prop 65. The consumer warnings are more restrictive. A professional product has some leeway. If they follow the consumer rules, they're automatically compliant, but they're allowed to try to justify other ones. The biggest justification difference is consumer washing machine. It's very difficult to prove the consumer will read the manual, so the warning can't be in there. But a medical device, they bloody should be reading the instructions before running it. You can put the Prop 65 warning in the manual. So that's the main difference. If you can justify why you're not putting the substance on for professional device, you might be able to get away with it, but it'd be pretty hard to justify. So occupational exposures, worker exposures, are compliant to these the consumer. They can try to they're allowed to justify other things, but it's pretty hard to do. So large size products must have long form labels on it, or its packaging or as an insert. The rule is in a brick and mortar sale, physical sale, the warning has to be provided before exposure. It's very strange reasoning for this, but theoretically, so a lot of this legislation is older, like 1980s, so it includes things like catalog warnings, like your old Sears catalog and stuff like that. But if you buy a product in a store, they theorize you could bring it home, open it up, see the warning, decide, hey, I want to bring this back, and you can close that and bring it back. So the rule is you have to be warned in a brick and mortar sale before exposure. Internet sale, they say, hey, you have to be warned before checkout, because if they ship it to you, you open it up and see the warning, it's very difficult to send it back. And it probably was, but not anymore. Totally different world now. But the internet sales, the warning has to be before exposure. Physical sales has to be, internet sales warning has to be before checkout. So internet before checkout to a California resident, brick and mortar before exposure. So it can be inside the box when you open it up and see it. So it doesn't, large product, it doesn't necessarily have to be in the product. It could be an insert, it could be on the bag, it could be on the packaging, as long as it meets those rules. Internet, no matter what, it has to be before checkout. It could be on the specifications page. It could be really advanced software that once you put your zip code in there and recognize your California resident and tells you. All of them are allowed. It just has to be before checkout. Lead is used in solder PCBA. We still have to report that. Prop 65, only if there's an exposure. Is somebody going to touch it? Chances are consumers shouldn't be touching the circuit board. It's a bad idea. However, repair technician might be. So you might have to have a lead warning in the repair manual, but not necessarily for the consumer. And so we'll handle all that for you. Prop 65, are the short long form warnings required to be directly on the product, or can they be included in the product documentation? So yeah, that's a really good question. Same thing, brick and mortar sale has to be before exposure. They can be in the manual if you can justify the manual be read. That's an important problem. It's actually one of the reasons why if you open up like a new modern electronic product, I was about to say some brands, you'll get a very short pamphlet in there with like safety warnings. That's an insert. The manual's online, but it's tiny little paper on safety warnings. Insert is allowed, but normally only professional products can put it in the manual. It's if somebody buys a blender, they're going to read the manual. The consumer product company's like, sometimes doesn't have to. So sometimes it can't be in the manual. If it's like this is a professional, he should not be approved to run this device without reading the manual. Then it can. Do we know to show test reports if requested, or we can go risk assessment materials? So TSCA is strict liability. You have to be compliant. If you're not compliant, it's about defending it. They don't care about supplier declarations. It's an unfortunate truth. If supplier declarations, by the way, help you be compliant, that's fine. You can do whatever you want for TSCA to be compliant. But if you're not compliant, all they care is if you tested something. So it's a very big difference. The TSCA is strict liability. You have to be compliant. You can get there any way you want. It's not like a technical file or whatever. No, you can get there anywhere you want. But if you're not, all they're going to care about is against the value of your sales. Did you do enough testing? Prop 65, test report is not required. However, it is a specific defense in a number. So that's a very long story. There are specific situations where the test report is a defense, even if they find a different exposure. It has to do with if you get a non-detect for a substance in a test report, then for the next year, it can't be prosecuted for that. If it's exposure related, there's a variety of rules. Test reports, though, are virtually the only defense for Prop 60. Well, it's only two. When we defend something with Prop 65, there's only two things that work. There are other things that can argue it down. There's only two things that win. Test report, or B, you prove that the product they bought is more than a year old from its manufacturing date and the current version doesn't have it. There's a limitation of liabilities of 1 year for Prop 65. So if what they acquired was manufactured over a year ago, it doesn't count unless your current version still has the same problem. So we've done a number before where they got a phthalated part from a bin from years ago. The new part for the last 2 years doesn't have it. That's a win because it's based, there's only a 1 year manufacturing date for Prop 65. Also, if you don't make the product anymore and it's manufactured over a year ago, also doesn't count kind of. Is there anything preventing somebody from using the proposed Prop 65 warning today? No, it actually specifically says you can use it early. It's right in the new text. If a product is not made in California, not repairable in California, would the product need a warning for circuit board or internal brass component? Normally, no. Normally, it depends on exposure. If nobody has any reasonable reason to touch it, we're not talking about unreasonable. You can rip stuff apart. That's unreasonable use. In reasonable use, if they have any reason to touch it, then the ingestion exposure isn't there. If it's not like you make a laptop and it's got nickel on the outside and somebody wears it like a necklace, that's also not reasonable. Nickel is a dermal, basically wearable Prop 65 substance. So if they wore a nickel laptop, that would be a Prop 65 problem, but it's not a reasonable use of your laptop. It's not a wearable laptop. Somebody puts a gold chain around and puts it on their chest. That's not a reasonable use of your laptop, I hope. So sorry I didn't get to everybody's questions. Oh, one more. PIP. Is PIP present as an additive or reactive substance? It's my understanding that DOPO is reacted in epoxy polymer, is no longer the polymer backbone. That is a fantastic question. Is the phosphated flame retardant additive or reactive? We do not have good data on that. One of the problems with substances not being regulated before, it's not good. TBP, the one without the isopropyls, is very commonly an additive flame retardant, not reactive. So it's very likely not reactive flame retardant. It's very likely an additive and therefore present. So if everybody else, what the difference is from a test perspective, tetrabromobisphenol A, which by the way is a brominated one, in your FR4 is fully reacted with the polycarbonates and becomes a brominated polycarbonate. Your tetrabromobisphenol A is no longer tetrabromobisphenol A, it's brominated polycarbonate, and you might think that's just linguistics. If we test for it and try to extract it, not dissolve it, extract it, we won't get tetrabromobisphenol A out of it because it's fully reactive. So that's a reactive flame retardant. What the question here is, a PIP a reactive one? So when it gets added, does it become a permanent part of the PVC? Generally with PVC, no. PVC is normally, it'll be an additive flame retardant. It won't become a permanent part of the PVC. Now the question for circuit boards, does it become part of the diglycerol ether BPA epoxy? Tetrabromobisphenol A does, because it looks just like bisphenol A, which is the backbone of polycarbonate. I would not expect this one to be fully reactive, but that's an extremely good question I'll look at. Right now, we're assuming it's an additive flame retardant and therefore be present still. If it's a reactive, it won't be present in that form, be a phosphated BPA polymer of some sort. So that's it for questions. If you have any more questions, feel free to reach out. I'll be happy to help on any of these subjects. We'll be sending out pretty soon to everybody registered, a copy of the presentation. Anybody needs help with compliance, contact us. Honest to goodness, Prop 65, we are really good at it. This is a real specialty virus. We will solve the problem. We'll make sure you don't get into trouble. And that's the main thing here. You're not doing it for fun. You're doing it because you have to do it. Prop 65 is over 300 prosecutions a month. You don't want to screw that one up. And the prosecutions are public. It's just not a lot of fun. So thanks everybody for attending, and I hope to talk to everyone again soon.